Okay, everybody, so every distribution we made today was an example of something called the binomial distribution. And I think you probably figured out now why the word binomial is what it is, because there's two outcomes that are mutually exclusive disjoint. In the chick's case, you're either going to get a chick or you're going to get a rooster once the pullet develops. And that's one of the requirements for a binomial, that you can only have two outcomes, one or the other. Now this comes really in handy in quite a few places. I mean, for example, either you get COVID or you don't. Either you have ADHD or you don't. Either you break your leg at Mount Bachelor or you don't. Lots of things can be treated as binomial. Even things that don't seem binomial might be restructured as binomial. For example, how's somebody going to pay for a service? They can pay with PayPal, they can pay with cryptocurrency, Apple Pay, cash, check, or you could simply say, are they going to pay with a credit card or are they not? Make it binomial. So things can be made binomial, which is one of the main reasons it's such a useful distribution. So that's the first requirement, two mutually exclusive outcomes. The second is, and this is not as obvious in the examples we did, but I'm going to tell you now, you have to have a fixed number of trials. So for example, with the rule family flock, we went to the store knowing we were going to get 4 pullets. We didn't say, Max, go in the store and get as many chicks as you want, because we would have come home with hundreds. So we went in with 4. Now why 4? There's actually a code in Bend that says for our size lot, you can only have up to 4 chickens. So we had that fixed number going in. And as such, we can then analyze it, right? We know the minimum number of girls was 0 and the maximum number was 4. So we have a fixed value of all the random variable values. Now the third requirement for a binomial is a little bit more slippery. We utilized it in all the examples we did today, but you have to be careful assuming it. So I told you in the first video that when I spoke to Joel at High Desert Ranch and Home, he said there's a 90% chance that a pullet that you select is going to be female based on the sexing procedure they do. So when you walk in and you look down and you see a bin of little fuzzy peeps, you can assume that 90% of those peeps are female. But then as soon as you start drawing them out of the bin, you start changing the probabilities. If you're looking for an analogy to this, think back to dealing cards versus flipping a coin. Every time you flip a coin, the probability is 50% that you're going to get heads or tails. But cards, if you pull a diamond out of a deck of cards, that means the chance of getting a diamond just changed. Now, here's the part that you make yourself feel better about. As long as you're taking a small sample from a super large population, then it doesn't matter that the probabilities are changing, because they're changing a very, very little bit. For example, we took 4 chicks out of these bins that had hundreds of chicks in them. So yeah, is it going to be exactly 90% every time? No. But statistically, probabilistically, it's going to be close enough to 90%. It might be something like 90.0002% or 89.9997% or something like that. So the 3 requirements again for a binomial: got to have 2 outcomes. Either something happened or it didn't. Fixed number of trials. So 4 pullets in this case. Now, we actually did 4 different distributions: 1 pullet, 2 pullets, 3 pullets, or 4 pullets. In your homework, you're going to do 5. But regardless, it's fixed at the beginning. And the third requirement is constant probabilities from each trial that you're doing in your experiment. And the trick with that one is that means you have to assume that the events are independent and not dependent. Dependent would be the cards. Every card that comes out affects the cards that are the probabilities of the cards that remain. That's dependent probability. Coin flipping is independent. The coin doesn't remember what it just flipped. Heads or tails, it's always going to be 50-50. As long as you can reasonably establish the probabilities are not affecting each other, then the binomial is just a ticket in a whole lot of ways. All right, so let's do a homework and let's see how to put it to use, and then in day 2, we'll take a deeper dive.